Reflection and refraction. When light enters a new medium, remember medium means material, some of the light reflects, bounces back, some of the light refracts, transmits through. You can see in this picture, you can see the person through the glass, and you can see the reflection of the building and the street signs because some of the light is reflecting off the glass and some of the light is going through the glass. I'm sure you've seen it at home when you look out your window at night, you see the reflection of yourself and the lights in the room, and you see outside. Reflection, the law of reflection, theta I equals theta R. This is on the reference table. Theta is just what we use for angle. Theta I means incident or incoming angle, and theta R means reflected angle. Now it's important that you always measure the angle from the normal. So normal means perpendicular to the surface. So here we have air and water. The normal is perpendicular up. So we measure the angle right here. It's 60 degrees. So what would the reflected angle be? So theta I equals theta R. The reflected angle would be 60 degrees. All right, refraction's a bit more interesting. You ever look into a glass and see how your straw looks bent? Well, that's refraction. Light bends when it enters a new material. All right, so we see these lines in the water cup are wavy when you look through the water cup. We have this swimmer spitting water, the cat's eye. I really like this picture. It's not a picture of a globe, it's a picture of a water drop with refracting a map from behind it. Looks like a globe. Um, This one, physics is fun. Don't worry, he's not actually decapitated. It just looks that way because when the light travels from the water to the glass to the air, it bends. So where his body is and where it looks to be are not in the same spot because light bends when it changes material. All right, so Snell's law, the law of refraction, n1 sine theta 1 equals n2 sine theta 2. N1 is the index of refraction for material 1. Theta 1 is the angle in material 1. N2 is the index of refraction for material 2. And theta 2 is the angle in material 2. And just like with reflection, we're going to measure our angles from the normal. Make sure your calculator is in degree mode. So if you have like a TI graphing calculator, TI-84, push the mode button and make sure it's set to degrees. Make sure it's not in radians. All right, so here's some practice. Number 9, a ray of light, F equals 5.09 times 10 to the 14 hertz, is incident on the boundary between air and an unknown material x at an angle of incidence of 55 degrees, as shown. The absolute index of refraction of material x is 1.66. Calculate the angle of refraction of this light ray. So, again, we measure from the normal. Okay, so we're measuring 55 degrees right here. So N1, okay, we have N1 sine theta 1 equals N2 sine theta 2. N1 is air. On the reference table, that's 1.00. Okay, theta 1 is 55 degrees. That's given. N2 is the index for material X. Material X is not on the reference table, but it tells us material X is 1.66. So N2 is 1.66 and solve for theta 2. So we have 1.00 sine 55 degrees equals 1.66 sine theta 2. We divide both sides by 1.66, and we have 1 sine 55 degrees divided by 1.66 equals 0.493. Now that's not equal to theta 2. We're not done yet. Sine theta 2 is equal to 0.493. So we have to get rid of the sign. You can't divide by sign. It's not a number. The way we get rid of sign is we do something called an arc sign or an inverse sign. Please don't call it a second sign, but those are the buttons you push on the calculator. You push the second and then sign. You get this sine inverse, sine to the -1. So theta 2 is the inverse sine of 0.493, and it's 29.6 degrees. Okay? Um, so remember the last step when we're solving for the angle, right? Because the angle's in the sign is you have to unsign it, and we do that by doing the inverse sign. Okay? That would be a good time to pause and try number 10. It's just like this one. You guys give it a try. When you're ready to resume, we'll go over it. All right. Number 10, a monochromatic light ray traveling in air is incident on the surface of a rectangular block of lucite. Lucite is a type of glass. The angle of incidence is 50 degrees. Calculate the angle of refraction. So we're going to do n1 sine theta 1 equals n2 sine theta 2. 1.00 sine of 50 degrees. The 1.00 because it's air. 50 degrees is the angle of incidence. So this is air, and we're at 50 degrees right here. Equals, we need the index of refraction for lucite. So you just look on the reference table. It's right there. It's 1.5. So lucite N2 is 1.5 sine theta 2. So we divide both sides by 1.5. So we have 1 sine 50 divided by 1.5. We get 0.51. Again, that's not the answer. We have to take the inverse sine of 0.51, and we get 30.7 degrees.